To find the inverse of our function informally, that just means we're going to take y equals our function, and we do the process that we've been doing, which is we switch the x and y's. So we've got x equals 3 minus 5y over y plus 1. Now, when we've got a fraction, we want to get it out of the fraction. Our goal here is to solve for y. And so since we've got two y's, we've got to do some work to be able to solve. We're going to multiply both sides by that denominator, y plus 1. Okay, and on the right side, that cancels out. On the left side, we're going to distribute the x. So x times y, and then plus x times 1 is x. And then we've just got equals 3 minus 5y. Okay, now everything that has a y, we want on one side of the equation. So we're going to go ahead and add 5y to both sides. We've got xy plus 5y. And whatever doesn't have a y, we want on the other side. So we're going to subtract x from both sides and get equals 3 minus x. Okay, now we're going to factor the y out of the left side. We're left with y times x plus 5 equals 3 minus x. And then just divide by the x plus 5 to solve for y. 3 minus x over x plus 5. Okay, so that we've got y by itself, so this is our inverse function. F inverse of x equals 3 minus x over x plus 5. Okay, now for verification of these two properties, we need to, for this first one, take f of f inverse of x. So f inverse of x, that's what we just found, 3 minus x over x plus 5. And, well, we're doing f of that thing. So f is this thing up here. So we have 3 minus 5 times this input, which is that whole thing, 3 minus x over x plus 5. And then over x, which again is that whole input, 3 minus x over x plus 5, and then plus 1. Okay, now there's a lot going on here, but a quick way to simplify is to just, when you have a fraction inside of a fraction, to just multiply the denominator, multiply by the denominator of that inside fraction on both top and bottom. Okay, now this fraction is 1, so multiplying by 1 doesn't actually change it, it's just going to change what it looks like. Okay, now we're going to go ahead and distribute. So I take 3 times the x plus 5, that's 3x plus 15. And then minus, here the x plus 5 cancels, and we just have minus the 5 times 3 minus x. So minus the 5 times the 3 minus x. And in the denominator, same thing here. We've got 3 minus x over x plus 5 times x plus 5 just becomes 3 minus x. And then plus, well, 1 times x plus 5 is just x plus 5. And now we just need to simplify. We get a 3x plus 15. And then distributing the negative 5, we get minus 15. And then plus x. Notice the plus 5x. Gotta be careful about that. Plus 5x. And notice that our 15s cancel. And we get 3x plus 5x on top there, which is 8x. I'll go ahead and finish that off there. In our denominator, the x's cancel, and we just end up with 8. Well, 8x over 8 is just x. Okay, so that's our first identity there that we've verified. Let me go ahead and move this work over just so that we can, oh, and I lost a little piece of it. Lost a little piece of it right there. And that was this. Okay, now we're going to do f inverse of f of x, and it's going to work pretty much the same way. Okay, we are doing f inverse of f, which is 3 minus 5x over x plus 1. Okay, so now we go ahead and apply f inverse to this thing. So this is f inverse, so we're going to do 3 minus that input, 3 minus 5x over x plus 1, over the input plus 5. So 3 minus 5x over x plus 1 plus 5. Okay, now to get rid of a fraction inside of a fraction, we multiply top and bottom by the denominator of that, which is just the x plus 1. So we get, well, 3 times x plus 1 is 3x plus 3. And then minus, here the x plus 1 cancels, so it's just that numerator, minus the 3 minus 5x. For our denominator, we take this fraction and multiply by x plus 1. Again, the x plus 1 cancels, and we just get 3 minus 5x. And then plus 5 times that, plus 5x plus 5, distributing the 5 there. And now we need to simplify. We get 3x plus 3. Distribute the negative, you get minus 3, and then plus 5x. And then now the 3 and the 5 combine to be 8, and the negative 5x and 5x cancel. So in the numerator, we get 8x here. The 3 and the minus 3 cancel. This is over 8, which of course is equal to x. So we've verified that second identity. Okay, now for our domain and range. So our domain of f is the same thing as the range of f inverse. Okay, so we just look at f, and we're dividing by x plus 1, so we know x plus 1 cannot be 0. X plus 1 not equal to 0, which means x cannot equal negative 1. So our domain of f then would be negative infinity to negative 1 union negative 1 to infinity, everything except for negative 1. And the range of f inverse is the exact same thing. We don't need to do any work for that because we know the domain of f is the range of f inverse. And then, let's move this over. We can do the domain and range of, we can do the domain of f inverse and the range of f, and it works the same way. They're going to be the same thing. Domain of f inverse, if we look at this right here, well, x plus 5 can't equal 0, so x cannot equal negative 5. Okay. Well, that means that it's negative infinity to negative 5 union negative 5 to infinity. And the range of f is then the same thing. Okay, so now we just want to graph both f and f inverse on the same set of coordinate axes. So in our calculator, we'll add a graph, and we're just going to type both of these functions in. So we've got, here's our f. So I'm going to do control divide to create that fraction. 3 minus 5x over x plus 1. And then hit tab to get another one, and we type in the inverse. Control divide 3 minus x over x plus 5. And hit enter there. And this, of course, we're looking for the symmetry across the line y equals x. Let me go ahead and graph that, y equals x. We see that they are symmetric across that line. Okay, I'm not going to draw that here. And that's simply this relationship that we're looking for. Okay, they are reflections of each other over, oops, that's not how you spell over the line y equals x.